Welcome to Menon's 5W8 channel, and today's topic is a very interesting topic called data science, right? So we're going to speak very briefly about what is data science and how it's changing the world. Now, one important thing in data science is it uses machine learning and AI as a new norm, right, in your entire principles. And this data growth itself, the reason why data science is picking up, data growth by itself is presenting new business opportunities for people, right? Because you can see that data is doubling or tripling every 1 year or 2 year or 3 year. It becomes very interesting for us to look at how do you capture this information for doing a lot of algorithms around it. And digital transformation is not very successful without this getting into this data science and then looking at what kind of algorithms you can actually look at, right? So a couple of cases where it's very interesting to watch how the customer is using it, right? So if you really look at an industry where there is billing and happening with a lot of customers, you can identify fraud basically, right? You can optimize your treatment by using less effective medical procedures by using data science. So it's possible that you can actually build your data science lab by which you can pull all your data, build these algorithms to actually capture and help the customer to really identify the frauds, right? So that's one example of where you can look at. So what does a data lab do typically if you build that for a customers? So you have actually capturing data from various sources. You need to experiment and gain insight. So we'll speak about this detailed into these algorithms of all this data science which is coming from machine learning and deep learning in the future sessions. But first of all, you need to get the data and experiment and gain insight from the data. And you also need to make it a self-running algorithm, right? Basically, it can recover itself, it can learn itself, okay? You teach it how to actually respond to various things. And you're creating an environment where the data itself can support innovation for you. The algorithms can be built into the machine, which can build and create new algorithms and as it learns on the fly. Okay, and this is going to be a way by which you can pull your data labs at your places. So the reasons why you build a data lab mostly in your organizations or within your horizontals or verticals is you can do data discovery, right? And there is a lot of hidden patterns and anomalies. Let's take an example. Now, if you really look at the credit card as a business, and if you really want to look at the anomalies in credit cards, what happens? You travel from country to the country and then you suddenly see some data issues in it. The first level kind of algorithms is already done by the banking company, right? It's no problem with that. But you have huge amount of data still lying out idle. So how do you pull all this data and look at data discovery? Maybe you want to combine the person's behaviors, his social media response, his friend circle. You may want to look at his demography, his country of travel. You might want to really look at which particular industry has he traveled, blah, blah, blah. So you can mix all this and create data discovery algorithms, right? Second, you can actually use the data lab to build and test your machine learning model for predictive analytics. That's very important, right? And let's remember one thing, that you're not trying to create something from zero. You need to blend whatever data you have creating out of it, the existing data, and then you need to bring in a new kind of reporting models. And it's important that when you're building a data labs kind of scenario, it's not an easy job, right? You need data engineers who are very good from a data aspect, from an engineering perspective. You need business analysts, right? And you need a data scientist who are good in statistics and kind of algorithms kind of thing. And then there's business leaders. You need to have multiple kind of job roles which are working together to make this data lab very successful. So let's speak about these roles, because we're talking about a reskilling channel and how do you create the future roles. The typical job role of a DBAs and data developer has to move into something new for the future. So one of the job role could be data scientist. What does a data scientist do for his bread and butter, right? He will build the model, he will train the model, right? So you have huge amount of data. Take the data, build the model, train the model, and keep doing new modeling kind of tool. That's the job of a data scientist. So what does a data engineer do then? He will integrate transform the data, and you will also do data accuracy, relevancy, whatever you're speaking about as a DBA into a new kind of world. That's a data engineer job, right? Typically the person can come from a DBA background, who's doing data integration background. The third kind of job is a business analyst guy who look at more from a data value. How is it impacting to the business, right? If you're coming from a retail industry, how does this particular data which is coming in is going to relevant to a specific area of retail business, okay? Specific business into healthcare, etc., right? What does the developer do? He does operationalize the models. So whatever is getting built, he need to really bring it together by using some kind of a coding and algorithms, right? And if you make these reports very actionable, okay, and if you can integrate with your existing applications and processes, you can create new custom application. You can also actually monetize the entire lab by putting a lot of things to work. Okay, some common use cases where we have seen this data lab and machine learning, etc., working together. You can actually do a personalized marketing content with data as service, right? You can actually take up all the data which is there and then go to a segment of people and tell, is this going to interest you? Now let's look at a very interesting market, employee hiring. I've not seen a very successful case, but identifying an optimal candidate by using these kind of data labs. How do you identify? He's in social networks, he's working in a current company, he's doing a lot of other works, and how do you really pull these data together and build machine learning cases? Okay, it can be used for logistics optimizations. So you could see that there are a lot of use cases where you can make these things work. Now in a typical architectural scenario, what are the components which will exist in a data lab or a kind of thing? So normally you might have a kind of a scenario for big data. Basically you need to have a lot of data models, R models, development tools. You might have analytics built on the top of it, okay, a lot of discovery algorithm, visualizations, how to deploy the model, that's another layer. And last but not the least, very important is you're talking about high intensity, okay, velocity, volume, right, variety of data. You need to have an infrastructure which supports it, right? So you need GPUs, optimized libraries, serverless kind of computing to support this kind of scenarios, right? So that's the solution pattern you can look at. You can look at something like a data source, which could come from any kind of data into your big data, and then you might do some kind of analysis to it and then get stored into the existing data. And you're also talking about a world where it's becoming very autonomous. You can build all your data science into your platforms, which can be smart by itself. Actually, when you tell autonomous, a lot of things happens through the data science kind of algorithms, right? So thanks for watching. This was a very preview video to talk to you about data science and how these different pieces work together and then to solve a problem of the customers. So please subscribe and continue watching these videos. Thanks.